Let's now introduce ourselves to the idea of a differential equation. And as we'll see, differential equations are super useful for modeling and simulating phenomena and understanding how they operate. But we'll get into that later. For now, let's just think about, or at least look at, what a differential equation actually is. So if I were to write, here's an example of a differential equation. If I were to write that the second derivative of y plus 2 times the first derivative of y is equal to 3 times y, this right over here is a differential equation. Another way we could write it, if we said that y is a function of x, we could write this in function notation. We could write the second derivative of our function with respect to x plus 2 times the first derivative of our function is equal to 3 times our function. Or if we wanted to use the Leibniz notation, we could also write the second derivative of y with respect to x plus 2 times the first derivative of y with respect to x is equal to 3 times y. All three of these, equations are really representing the same thing. They're saying, okay, can I find functions where the second derivative of the function plus 2 times the first derivative of the function is equal to 3 times the function itself? So just to be clear, these are all essentially saying the same thing. And you might have just caught from how I described it that the solution to a differential equation is a function or a class of functions. It's not just a value or a set of values. So the solution to a differential equation is a function. Is a function or a set of functions or a class of functions. And it's important to contrast this relative to a traditional equation. So let me write that down. So a traditional equation, I guess I could say, maybe I shouldn't say traditional equation. Differential equations have been around for a while. So let me write this as maybe an algebraic equation that you're familiar with. An algebraic equation might look something like, and I'll just write a simple quadratic, say x squared plus 3x plus 2 is equal to 0. The solutions to this algebraic equation are going to be numbers or a set of numbers. We can solve this as going to be x plus 2 times x plus 1 is equal to 0. So x could be equal to negative 2 or x could be equal to negative 1. The solutions here are numbers or a set of or a set of values or set of values that satisfy the equation. Here it's a relationship between a function and its derivatives. And so the solutions or the solution is going to be a function or a set of functions. Now let's make that a little bit more tangible. What would a solution to something like any of these three, which really represent the same thing, what would a solution actually look like? And actually let me move this over a little bit. Move this a little bit so that we can take a look at what some of these solutions could look like. And let me erase this little stuff that I have right over here. So, and I'm just going to give you examples of solutions here. We'll verify that these indeed are solutions for, I guess this is really just one differential equation represented in different ways, but it'll hopefully appreciate what a solution to a differential equation looks like. And that there is often more than one solution, or there's a whole class of functions that could be a solution. So one solution to this differential equation, and I'll just write it as our first one. So one solution, I'll call it y1, and I could even write it as y1 of x to make it explicit that it is a function of x. One solution is y1 of x is equal to e to the negative 3x. And I encourage you to pause this video right now and find the first derivative of y1 and the second derivative of y1 and verify that it does indeed satisfy this differential equation. So I'm assuming you've had a go at it. So let's work through this together. So that's y1. So the first derivative of y1, well, this is going to be, let's see, we just have to do the chain rule here. Derivative of negative 3x with respect to x is just negative 3. And the derivative of e to the negative 3x with respect to negative 3x is just e to the negative 3x. And if we take the second derivative, y of y1, this is equal to, same exact idea, derivative of this is negative 3 times negative 3 is going to be 9e to the negative 3x. And now we can just substitute these values into the differential equation, or these expressions into the differential equation, to verify that this is indeed going to be true for this function. So let's verify that. So we first have the second derivative of y. So that's that term right over there. So we have 9e to the negative 3x plus 2 times the first derivative. So that's going to be 2 times this right over here. So it's going to be minus 6. I'll just write plus negative 6 e to the negative 3x. Notice I just took this 2 times the first derivative. 2 times the first derivative is going to be equal to, or needs to be equal to, if this indeed does satisfy, if y1 does indeed satisfy the differential equation, this needs to be equal to 3 times y. Well, 3 times y is 3 times e to the negative 3x. 3e to the negative 3x. And let's see if that indeed is true. So these two terms right over here, 9e to the negative 3x, essentially minus 6e to the negative 3x. That's going to be 3e to the negative 3x. Which is indeed equal to 3e to the negative 3x. So y1 is indeed a solution to this differential equation. But as we'll see, it is not the only solution to this differential equation. For example, let's say a y2 is equal to e to the x is also a solution to this differential equation. And I encourage you to pause the video again and verify that it's a solution. So assuming you've had a go at it, so the first derivative of this is pretty straightforward, is e to the x. Second derivative is one of the profound things of the exponential function. The second derivative here is also e to the x. And so if I have, the second derivative, let me just do it in those same colors. So the second derivative, it's going to be e to the x plus 2 times e to the x plus 2 times e to the x is indeed going to be equal to 3 times e to the x. 3 times e to the x. This is absolutely going to be true. E to the x plus 2 to the x is 3e to the x. So y2 is also a solution to this differential equation. So that's a start. In the next few videos, we'll explore this more. We'll start to see what the solutions look like, what classes of solutions are, techniques for solving them, visualizing solutions to differential equations, and a whole toolkit for kind of digging in deeper.